Hello, and thank you to this short demonstration of the L1 substate operation of the U4301B PCIe analyzer and U4305B PCIe exerciser. My name is Don Schenecker. I am the product manager for these products, and I would like to demonstrate what we have implemented on these tools to analyze these new L1 substates. First off, the need for this analysis is because the drive for these is to accomplish very low power states for battery-based applications of tablets, handhelds, embedded systems, and that power savings comes with a trade-off. It causes lower performance for PCIe, and so you need tools to analyze and understand what those changes are. The power savings are very significant. The typical power usage of a Gen 3 by 1 link is about 1 watt per lane. And that's across, if you're using a by 4 system, you're using about 4 watts. Well, the L1 state significantly reduces that to about 20 milliwatts of operation. But it has a very fast recovery time back to power or to data transfer state of about 4 microseconds, less than 5. The new substates of L1.1 first turn off the clock, the PLL, and the transmit circuitry. And so that gets your power usage down to less than 500 microwatts, but at a cost of 5 times the recovery time. The substate of L1.2 additionally turns off the keeper voltages, but that gets you down to tens of microwatts, but again increases the recovery time. Well, you need tools in order to look and see exactly the cause of that. Well, we have implemented that on the U4305B PCIe exerciser by taking control of the clock request pin on this exerciser card. That pin is the shared circuit, or the clock request line, that is shared between the upstream and the downstream. So whether you're working as an upstream component for testing that, or testing a device that's going to be added to a link, either the root complex or a device to the link, that shared pin is used by both to shut off the clock. L1.1 shuts the clock off. Additionally, 1.2 shuts off the keeper voltages. And the exerciser is implemented to support testing of both of those. Now let me do you a quick demonstration of exactly that functionality. Here I have the default configuration of our exerciser. Right now you can see here's our different setting parameters. On the right-hand side is our link information. Right now we have no link in operation. That's because we haven't brought it up yet. So first thing I want to do is go to General Settings, and in the General Settings, there's a number of different tabs for configuration. First off, I'm going to test a device. So I select my session type of I'm connecting to the downstream. I'm going to operate as the root complex, and I apply on that. And that configures my analyzer operation. I don't need to make any changes to any of these other settings except for power management. And in power management, what I want to do is enable, first off, L1 testing. So I enable that, setting some time in here of what I want to exit into the power savings mode into L1, and also an exit frequency. L1 substate, additionally, I want to initiate L1.1. Let's go 400 nanoseconds after we enter L1. Let's enable L1.1. Well, we won't test L1.2 yet. We want to assert the clock request in all non-L1 states. You can even do wrong configurations. And then these transmitter power voltage on and off, that ties to the L1.2, so they're currently grayed out. There's also settings here for L0S and the recovery times. We're not worried about that right now. So now I apply those parameters. Now, in addition to the actual power savings, I need to set a couple parameters in the configuration space. So I go to configuration space. There's lots of different spots available, and from PCI configuration or the common header, there's a power management, which has to do with L0S and L1. What we want to get to is the PCIe capabilities. If I go into that, here's I get in my PCI Express register, device capabilities. I need to scroll down until I get to my link configuration area. So I scroll down through this link, and now I see the link capabilities register. In the link capabilities register, first off, I see active state link power management support. I need to enable L1 support operation. I also, just a little bit farther down in the link control register, there's active state power management control bits. I need to enable that to L1. I press apply, and that's all the configuration I need to now let the device go in and out of the states. So now across the top, I go to my link, start link training, click on that, and I see my link is up and active. I'm operating as the root complex, testing the device. How do I know if I'm going into the L1 substate? Well, now I go into a quick LTSSM test. LTSSM test has all my basic operations for testing that configuration. I need just a basic what's the status. So I expand that listing, and there's a capture state transitions. This capture state transitions starts capturing those transitions for a maximum of 512 state transitions. Yeah, let's just see what's happening here. So I run this test. So it opens it up, starts the capture, and I can see it capturing a list of changes here. So over that time, what we see is a timestamp for each event. It was in L0 state at this timestamp, entered into L1 just a few microseconds later, 10 microseconds later, went into L1.0 idle, went into L1.1. So that was just took about 3 microseconds to get into L1.1 idle. Then here's it's coming back out, and you can see the time difference there was about 100 microseconds. Then it went through recovery. The clocks actually came back, the signal was there, it locked onto the signal, and back into L0. And you can scroll through this list and see the timestamps as that link is going in and out of L1 substate over and over again. Great, great validation. What if I want to do a little more testing of true algorithm type analysis of that? Well, there's an additional mode down here of going into a test bench. My test bench is a series of scripts for automated testing. Under this test bench, there's NVMe testing. There's also PCI Express testing. I want to access Keysight contributions L1 substate operation. Expand this over. There's different tests for ASPM L1.1, 1.2, 1.0, and then PCI power management 1.1, 1.2. So I can go through different modes. Before I run this test, I want to make a quick change so it doesn't keep going in and out of state. I want to get it into just a normal, valid state. So I'm going to shut off the transitions into the L1 substates of my device configuration. And now I can select this test, entry into that, and I select Run. It has an automatic script to initialize some things, and I can see that down here as it begins execution. It checks the configuration space, sets those parameters, and begins sending memory read packets, verifying the LTSSM state operation 1,000 times. So it's doing this test over and over and over again to make sure that I successfully enter and successfully exit within reasonable time periods for this state transitions. And I can go through each one of these as it does this validation and track through. And it's verifying that operation for each one of those. So we successfully did that 1,000 times in and out of L1.1. Great, great testing in there. Now I want to look at an additional parameter. If I look at want to capture the data for this link, I need to look with my analyzer. My analyzer is able to capture the data using a standard scope probe using the sideband signal acquisition. While data is flowing across my acquisition points, this probe is connected to some point on my target, whether it's an embedded signal or any one of the interfaces. I can bring that signal back into my analyzer, and this will work with the U4301A or B analyzer. Just need the new analysis software. So I connect up to capture that data. Let me bring up my analyzer. So first thing I want to do is just show you my configuration. I'm using a slot interposer, which is configured for automatic lane width. So whatever's going on across this link, it's going to capture that data and automatically capture that. To capture a little bit more data, I'm going to capture setup, increase my buffer size to 8 megabytes. Okay, click OK. That's in my configuration. My trigger menu is what do I want to capture. I have my filter and trigger capabilities here. Right now I'm going to filter is off, it's storing everything, but I want to capture these clock requests. Normally we'll ignore those, but if we want to analyze those, we turn on that sideband acquisition, enabled, and we're OK, click OK, and we're set to capture. So now let me start my test again. I'll run that test again. So it begins running this test over and over again of entering the LTSSM state. I bring up my analyzer, do a data capture. Capture, processing, and as soon as it fills the buffer, it will stop and show me exactly what occurred across this link. So in my trace of I see a clock request, I see the recovery signals of the data going across the link. I'm in the LTSSM, press a compute. It processes 100,000 packets and showing me these transitions of L0, L1, L1.1, L1, and then receiver lock as the signal recovers. So if I want to go to any point, I can jump to the L0 state and see the memory read packets, the updates flow control, completion packets, exactly what's occurring across this link. And I can capture all that data, and here it's going back into the L1 state again. And here's the clock request being deasserted for this operation. So I can capture all that data. I can jump to any one of these points. I can see that there were 26 transitions into L1.1 and back out again. And so it has all this data. As I scroll through my packet trace, I can see all the additional packets. If I want to collapse that down, there's now a compact mode. I can compact that down and see that the recovery, there were 413 TS1s, 1,200 on the upstream side. So it captures that to get back into the memory read packet, and I can see exactly what occurs there. If I want to see this kind of flow control, if I go to Traffic Overview, I do a compute, and it will give me a complete count of all of these packet events across the link and what occurred there. And I can see the counts. If I chart that, I can see that this entire transition, this trace was about 900 milliseconds long. And I can see where every one of those transitions occurred in and out of the L1 substate. Extremely valuable tools. Now I want to show you one additional point about the analyzer is you can link in an oscilloscope. So you can measure the exact power usage of your device and overlay that with exactly when things happened in your packet trace. So you can see of what happened to my power usage as training occurred, as data transfer occurred, as it went into an idle state. And you can see all the power usage, the delay times, the power usage, and do all the calculations. So you can calculate it. What's the voltage real like? What's the current usage? What's the power usage for any one of these states in here. So I hope this demonstration has been useful, and I thank you very much for attending. Bye-bye.